Steam boilers on ships produce pressurized steam for heating, cargo systems, fuel heating, and auxiliary power. They are critical to safe and efficient ship operations. This video explains common boiler types, main components, the steam generation cycle, control systems, and routine procedures for startup and shutdown. Auxiliary boiler. A small independent boiler used for steam when the main plant is offline or for accommodation heating services and systems on board. Water tube boiler. Water circulates in tubes heated externally by combustion gases, preferred on ships for fast response and high pressure operation. Why steam remains important. Steam provides reliable heat, sanitary systems, cargo heating, and drives turbines and pumps where electrical alternatives may be limited. We will proceed through components, the steam cycle, control, and safety systems, then practical procedures and maintenance advice for safe operation. The primary parts are the furnace, water, and steam drums, tube banks, burner assembly, and outer shell or casing that contains the furnace. Steam drum. The top vessel where generated steam collects and separates from water before leaving to the steam header. Water drum and circulation. Water collects and circulates through tubes. Natural or forced circulation maintains heat transfer and steam separation. Economizer and superheater are integral. The economizer preheats feed water. The superheater raises steam temperature to improve efficiency and dryness fraction. Feed pumps. Feed water valves and traps transfer water into the boiler. Level gauges, modulating valves, and interlocks maintain safe operation. Steam distribution includes the steam header, stop valves, and branch lines to service points such as steam turbines, heating and cargo systems. Combustion of fuel in the furnace produces hot gases. Heat transfers through tube walls to water, creating steam through boil and evaporation. Drum circulation ensures cooler water flows to heated tubes and steam rises to the steam drum. Separation devices remove moisture from steam. Key term, dryness fraction, the percentage of steam that is dry vapor. Superheating and separators improve dryness for efficient use. Steam flows to the header where stop valves control supply to consumers. Pressure-reducing valves and regulators match steam to demand. Condensate returns from users to the feed tank. Condensate pumps, traps, and drains prevent water hammer and recover heat into the feed water system. Blowdown removes concentrated dissolved solids from the boiler to control water chemistry and prevent scale and corrosion in tubes and drums. Automatic controls regulate pressure and water level. A pressure controller modulates fuel input, while level controllers operate feed pumps and valves. Key safety device. Safety valves lift at set pressure to prevent overpressure. Regular testing ensures they operate reliably under load conditions. Low water level alarms and trips are essential. Low water conditions risk overheating tubes and catastrophic failure if not automatically isolated. Flame detection and fuel shutoff interlocks protect against flame failure. Flame scanners and flame rods confirm stable combustion before opening fuel valves. Modern automation uses PLCs and remote monitoring for alarm logging, trending, and fault diagnosis. Redundant systems improve reliability and safety. Emergency actions include isolating fuel, venting steam to a safe dump, and following ESD procedures. Crew must know manual overrides and muster points. Pre-start checklist. Verify oil and water levels. Feed tank condition, safety valves, drains closed, and control power available before any ignition. Light up sequence. Purge the furnace to remove flammable gases, establish stable combustion, then gradually increase firing to reach operating pressure. During normal operation, monitor pressure, level, furnace temperature, and flue gas. Adjust fuel and air ratio for efficient combustion and low emissions. Shutdown steps. Reduce firing. Allow cool down under controlled conditions. Secure fuel supply and isolate steam lines once pressure is safe. Routine maintenance includes tube inspections, cleaning economizer surfaces, testing safety valves, checking water chemistry, and maintaining burner components. Summary: follow procedures, monitor instruments, maintain water chemistry, and train crew regularly. Safe boiler operation protects equipment, cargo, and personnel.